Our instructor was Dr. Khan. The team consisted of Kevin Caballero, Francisco del Val, Arturo Garcia, Alejandro Hernandez, and Alejandro Ornelas.
The objective is to build a multifunctional walking cane that utilizes a microcontroller, sensors, and actuators to assist the visually impaired in navigating through a particular area safely. In this case, the location will be UTEP. A color sensor will be used to follow a color-coded path that leads to specific areas throughout the university, while vibration motors will be used to deliver haptic feedback whenever the cane is outside of the path. An ultrasonic sensor will also be used to alert the user when an object is in close range, triggering an alarm. Once the cane is not in use, a servo motor will be used to protect the components by moving a plastic cover on top of the components.
The system begins in an idle waiting for 2 input options. If button 2 is pressed, the color options will cycle, allowing 4 different path selections. Corresponding pulses from the vibration motor will differentiate the path options. If button 1 is pressed, the system becomes activated and the servo cover moves to reveal the color sensor. The system is now in a continuous loop, starting by reading data from the color sensor. If the color selected is not detected, the vibration motor will turn on. If not, the motor will be off. The ultrasonic sensor measures distance, and if the distance is less than 30 centimeters, the buzzer will turn on. If not, the buzzer will remain off. The system then checks if button 1 has been pressed. If yes, the system goes back to the very beginning to idle. If not, the loop continues back to reading data from the color sensor.
To initialize the cane, we select the desired color, which in this case would be the red path if we want it to go to the UGLC. As we glide the cane across the floor, it will begin to vibrate once we are deterring from the intended path, only stopping when we put the cane on the track. To go to a different destination, you can change the settings on the cane to select a different color to be tracked. Suppose we are in close proximity to an obstacle. That is where the ultrasonic sensor will proceed to alarm the user. Once deactivated, the cane will retract a small shield to protect the hardware when not in use.
In conclusion, we added buttons to the handle of the cane that are used to initiate the system and decide which color the vibration motor will react to, while the ultrasonic sensor simultaneously prevents collisions, alerting the user with a buzzer. 4 different colors can be selected by the user in order to reach a desired location, and an easy transition for the user to operate the system because it uses a traditional method of navigating while aiding it to be safer and reliable. For the future, we would like to equip the system with an automatic leveling system to allow the color sensor to maintain a constant distance from the floor to optimize sensor outputs, manage the wires and components to allow the cane to fold for easy storage, and calibrate the color sensor to be able to detect color paths on reflective surfaces and avoid readings from ambient colors. We want to thank Dr. Khan for his knowledge, guidance, and comprehension, and also thank Professor Sugasti for his insightful lectures. And these are the references that we use to help us with our code.